Okay, absolute value of a function. So you all have the worksheet, it's open, it's in front of you. We have a table of values shown for the functions y equals 2x minus 6 and y equals the absolute value of 2x minus 6. So here is a lot of stuff. When I'm saying here is, you're not actually going to see it on the video, right? So in this column here is y equals 2x minus 6, and we need the absolute value. So what is the absolute value of negative 6? 6. Of negative 4? Negative 2. What's the absolute value of 0? 2. 4. 6. Is there an echo? Okay, so we're going to use that table of values. We're going to sketch the original graph, 2x minus 6, and then the absolute value graph, okay, on the grid shown, and then we'll compare the graphs. So I will do the original graph in red. And so all we got to do is find the points. So 0, negative 6, 1, negative 4, 2, negative 2, 3, 0, 4, 2, 5, 4, 6, 6. Okay, and we draw that. Do I join these points? Yeah, it's a straight line. It's a continuous function, right? I'm just going to get a couple more. It looks like 2. So I'm just going to follow the pattern out a bit. Give me more points. Okay, so here in red is the original graph. And let's use green, which for some reason, why don't I have that in as a tool? Let's use green. And I might change line thickness. That's green. I don't know. So use green and we'll graph the absolute value. So what's the difference? Well, now it's 0, 6. Okay. Instead of 1, negative 4, it's 1, 4. Instead of 2, negative 2, it's 2, 2. And this part of the graph, I'll just be going over in green, right? Nothing changed. None of these values here, all these values stayed the same. It's these values, well, I guess that's included there. It's these values here that changed. Okay, so we draw that. Okay, so we've drawn both graphs, right? One in red and one in green. And it couldn't hurt if you have colors, you know, it couldn't hurt for you to do stuff in some different colors either, right? Because you can refer to them then and say, well, the green is the absolute value graph, right? The red is the original graph. I worked out the values. 6, 4, 2, 0, 2, 6. How do the graphs compare? That's a big question right now. How do the graphs compare? This is the interactive portion of our program. Feel free to interact. Yeah.
When y is below 0, the absolute value graph is mirrored in the x-axis.
Okay, mirrored. So we'll call it a reflection, right? Because that's the words we've been using. So how do the graphs compare? They're the same when x is greater than 3. When x is greater than 3, they're the same. When x is less than 3, the original graph is reflected in the x-axis. Okay, so the original graph. So let's write something like that. So when x is greater than, they are the same. When x is less than 3, the absolute value graph is a reflection in the x-axis. Of the original graph. Period. Okay, Questions? There's a worksheet. Nonsense. Okay, questions? Seeing none, remember this time you get to interrupt with questions because it's live. We're going to do the same thing now, only we're going to do it for a quadratic function, right? Not linear, quadratic, or a parabola, right? It's a parabola. So we filled in a table of values for this parabola. Now if I was graphing this, I would probably prefer to have it in vertex form, but that's not the form we have. And we certainly can graph off of a table of values. So let's fill in. Here we use the thin red line. So what's the absolute value of 12? 12, 5, 0. What's this one become? 3. And then the same, right? So we have we have 3 sets of 3 numbers, 2 of which are the same because they're already positive, right? And only 1 set of which changes because the original graph, when we go to draw it, the original graph was negative there. Okay, so let's graph these. Whoops. So we'll do the original in a thin purple line. Okay, negative 1, 12, 0, 5, 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, 5, 0, 6, 5. We're just getting symmetrical now about the axis of symmetry, right, which runs through 3. So, and then 6, 7, 12. Okay, what do I do with these points? Join them up, right? Because it is a parabola. And then we'll throw some arrows on there. And it's nice to have as many points, right? So when you have to graph stuff like this Thursday, if you're asked to graph stuff on the test, then show lots of points, right? That way if your line isn't the greatest line, okay, remember, do not V a parabola, like don't come down to a sharp point. It's a nice rounded bottom on it. Okay, it doesn't come to a V. All right, and what, I didn't even know, is that what we were supposed to do? I'm leaping ahead here. Use table values, sketch the graph, and the graph on the grid shown. How do the graphs compare? Okay, so we've got the one graph. Let's do the other graph in red. So a number of these points, well, any values that were positive to begin with, positive are actually 0, right? Are the same. So these guys are the same, but these guys differ. So 2, negative 3 becomes 2, positive 3. 3, negative 4 becomes 3, 4. And 4, negative 3 becomes 4, 3. So this part of the graph is going to be the same until we hit 0, at which point it's then going to kind of bounce off. Well, it's doing the same thing it did before, right? It's reflecting. And then that part is on top. Okay, a moment. My question is about drawing the 2 graphs, or the drawing of the 2 graphs. Is good. Purple to red. Red that jumps back up. Use tables of values. We did that. How do the graphs compare? Okay, so what's the comparison then?
When x is greater than 1 and less than 5, it's a reflection on the x-axis.
Okay, so when the x values are between 1 and 5, then it's a reflection in the x-axis. So they're the same. What do we say? They're the same when x is less than or equal to 1, or x is greater than or equal to 5, and a reflection of, what's the equation? Y equals x squared minus 6x plus 5. When x is between 1 and 5. Okay? So in other words, where the original graph is negative, on the absolute value graph it's reflected, right? No, wait, where does that say at the bottom? The graph of y equals the absolute value of f of x is the same as the graph of y equals f of x, except the portions of the graph y equals f of x that are below the x-axis are reflected in the x-axis. The points on or above the x-axis are said to be invariant points because they remain unchanged after transformation. Right? So if we think of absolute value as performing some transformation on this, it is transforming those points that have negative y values into points that have positive y values. How does it do that? You know, really, well, let's think about this in a sec. We'll go to the next page. Because it says that at the top as well. But if you think about the definition of the absolute value function, right? So absolute value of x is equal to, well, it's equal to x if x is greater than or equal to 0, right? So if x is 12, it's just 12. If x is 15, it's just 15. But it's equal to negative x if x is less than 0, right? And what does negative x do? Well, we know what negatives do to parabolas, right? We know that they reflect them so that they open down. So replacing your x with a negative x, or putting a negative in there, gives you a reflection in the x-axis. Okay, so that's why we're seeing this reflection in the x-axis. We're saying if the x values are negative, then take the negative of them. Take the negative of a negative, which gives you that positive value. That's what absolute value does, right? Okay, graphs are shown, sketch on these same grids, sketch the graph. Okay, and so all this stuff's going to come up on Thursday, right? You're going to have to sketch grid graphs, and here's a graph of something, or graph this particular thing, and then graph the absolute value of it. Or here is a graph the absolute value. So on the same grid, sketch the, now in this case we're not defining the graph, right? There's no equation for it. There's no set of ordered pairs. It's just, here's a graph. Draw me the absolute value. So you say, well, this red part here that's below is going to reflect up above. So this part here is going to be reflected in the x-axis. So we can choose some representative points. This is 12, negative 2. So at 12, it becomes positive 2. At 15, where it goes through negative 4, it's going to become positive 4. And at 18, where it becomes negative 6, it'll become positive 6. And so the red branch of the graph that's to the right, that's below the axis, is reflected so that it becomes up above the axis, right? In other words, all of these negative y values, where the y values are negative here, become positive y values. So the negative 2 becomes positive 2. The negative 4 becomes positive 4. The negative 6 becomes positive 6. Okay, question about that first graph? Good. Second graph. Again, we have a portion of the graph that will be invariant. Okay, I'll just sketch over it in red because it's already red. But this portion here remains invariant. Invariant just means it does not vary. And what do? We take the negative values and they will become positive. So I'm just going to find a point. Here's the point 2, negative 6 will become the point 2, 6. And here's the point negative 5, negative 6 becomes negative 5, 6. Okay, this is not really a straight line here, right? So we don't want to draw it as a straight line. It's just a slightly curved line. Okay, so it's just going to curve a little. And same thing on this side. Okay, that's a lousy curve there, but you know, you kind of get the idea, right? That's why we show points. That's why you show points. So when I'm marking it, yeah, I went through the right point. You know, it's not the greatest line, but then I don't draw the greatest lines either. So I think we're good there. Okay, questions? No, good to go. Okay, do they have any questions below? What are they asking? Oh, more. There's more, but wait, there's more. Okay, so same deal, right? This is the negative portion of the graph. It's going to become positive. Just open like that. This is the negative portion of the graph. And this is the negative portion of the graph. Okay? And then on this one here, this is the neg. I'm just going to find kind of the point here. Let's say that's at about 5.5-ish, so about up there. Just give me an idea as to how to draw this. Okay, and it doesn't go through. And same thing over here. So this is no longer part of the graph, right? Same thing over here. This is no longer, or this is not part of the absolute value graph.
Mr. Yannerman, do you need to like circle those or like spread it out?
No, you just need to draw in what it should be.
We're actually drawing. Since those two don't really have like a whole lot of clear points, will you be marking it based on like if it's really accurate?
No,
Just, like,
it's because we'll say sketch. So
just basic shape.
yeah, basic shape. Like if you take this and flip it up to like 15 or 20 and then come down, then yeah, I'm not giving you marks. I mean that, you know. But does it would you know? Am I measuring? Is that exactly like 5.75? No. You know, does it come somewhere between 5 and 6? Yeah, you know. Does it? You know, but if you do stuff that doesn't look like it, so if you do like, then no, yeah, it's not gonna, you know.
When we graph it, do you actually want us to use different colors? Okay.
Well, you know, it'd be nice if you did, but it's not required. No, we'll say sketch the graph. I mean, you're mostly working in pencil. There'd be possibly one or two exceptions. You're mostly working in pencil, so that's easy enough to see. And nice thing about pencil, of course, if you blow it, then you can erase it. You know, you can clean it up. If you're doing stuff in pen, then you know. Okay, good with this? All right. Moving on. The graph of y equals the absolute value of f of x is shown. Determine the possible equations of. In other words, what might we have started with to give us this as an absolute value graph? So you could say, well, this part here might have been where? It might have been below. Or this part here might have been below. Okay, so we're just going to do this one at a time. Let's just say, okay, let's say that this left branch of this was below. So I want some points. I'm just going to, that's at 1, and that's a 2, and this is 3. Okay, so let's say we started with this green graph, and that was the original function f of x. When we took its absolute value, it then became the black graph, right? Part of which is hidden under the green there, but became the black. And what's the equation of this? So you say, well, what kind of shape is this? It's a straight line, right? What do we do for lines, right? Line is y equals mx plus b. Yep. Well, but we need a value for m and for b. So what's b? 2. So y equals something times x plus 2. What's the something? What's the slope of this line? 1/2, right? And you can just get that off of here, right? Go up 1 over 2 plus 1 plus 2. Up 1 over 2 is positive 1/2. And so the equation of the green line is 1/2 x plus 2. Okay, again, just slope, counting slope off of the grid. Okay, and y-intercept, just getting the y-intercept off the grid, right? Slope, just 1, 2, or you know, you could say to go from here, I went 1, 2, 3, 1, 4, 5, 6, which is 3 over 6, which is 1/2. Okay, questions on that? So that's the green line, where we said that this half of the graph was originally down here and was reflected up. Right? Or, now I can do this, I'm just going to wipe this out, we'll just start over. Or, originally, it was the right-hand portion of the graph, this portion here, that was below the axis, so what do we got? That. So we'll say originally the right-hand part of the graph, the black line that's above, was originally below. And so this red line becomes the original graph, the original y equals f of x, which is a straight line. And what is the y-intercept? -2. And what is the slope? 2. Well, it's negative because I'm going down. -1/2. So -1/2 x minus 2. Now, you know you can verify these on your calculator, right? And as we move through this, we're going to verify. We'll be doing some of these on our calculators as well. So make sure your calculator's handy.
So either one is right?
Either one is right. Well, or they're both right, actually. So you may need both of them. If I ask you what are all the possible equations that could have led to this, then there are 2. Right? Same thing with part B. I mean, in part B, either originally it looked like this, right? Originally it opened down. So we don't know. All we know is that a part that was below, so maybe this part here, the red part, was below the axis. And this is the original, so just in red. There's my original. Okay, let's get the equation of this. Well, we know, right, it's ax minus p squared plus q. Okay, that stuff's never going away, right? First unit stuff, quadratic functions, is never going away. And here it is, we're doing absolute value now. That's part of it though, right? It's part of figuring out. Okay, we got a vertex. We got a vertex at 2, -2. And that gives me p and q, so all we need is a. So we can eyeball it, or we can do it algebraically. Okay, so normally I go over 1. I should be going up 1, but I'm going up 1, 2. Over 1, up 2. What's my a value? 2. So we get y equals 2. X minus 2 quantity squared minus 2. Yes? No? Thumbs up? Good? Okay, I'll give you a moment. Copy that down, and we'll do the other one, right? Because there's 2 possibilities. Maybe it opened down, and this part was originally the positive part. Okay, so let's just clear this. I like the lag on this. Lag. Okay, so maybe the blue is the original. In which case my vertex is now at 2, 2, and my a value is negative 2. So y is negative 2, x minus 2 squared plus 2. Okay, so both of those are possible equations. In a multiple choice question, we could say a possible equation, so here's y equals here's y equals the absolute value of f of x, and we ask in a multiple choice, a possible equation for f of x is, and then you get 4 choices, right? One of which is correct, and 3 of which simply look reasonable. Okay, anything on this page, this section yet? It's not on this page, but go ahead. All right, moving along. So now we need our graphing calculators. Well, not now, but we will in a second. For y equals, now this is the method that you're going to use, right? And we're going to do one linear and one quadratic. Okay, so you want to be paying attention is, okay, when I get this, how do I do this type of problem? Okay, and what are all the possible things that are involved in this problem? Okay, for y equals the absolute value of negative 3 halves x minus 3, we're going to sketch the graph by first sketching the graph of y equals negative 3 halves x minus 3. In other words, we're going to strip off the absolute value signs and just say, let's sketch the original function. Okay, and then we're going to use graphing technology to verify that graph. All right, so we should know what this looks like. It's a line. It has a y-intercept of negative 3, and it has a slope of, use 3 over 2, because 1.5 is not good for graphing, right? Like if I'm graphing, so it says go down 3, 1, 2, 3, and write 2. Go down 3 and write 2. Now I've run out of space, so I can go up 3 and left 2. Up 3, left 2. I always just like to, I like to fill in the dots all the way. Okay, because then they should all nicely line up, which may mean that you might want to bring a ruler. If you got to draw a straight line, it's nice to have a ruler, right? But because the odds of me getting a straight line going through all those points are fairly slim. I expect a better job out of you. It's a lot easier, trust me, with paper and pencil than it is with a pen on the smartboard. So, let me clean up this middle. That's just kind of. Okay. Close enough. Use graphing technology to verify. Okay, so let's get out our graphing calculator, which I don't have out. So, hang on. I will pause. Okay, so let's graph this. What do we want? Y equals. I want y equals. Negative. I'm going to put the slope in brackets because I'd just like to do that. 3 halves x minus 3. So, and that looks like what we have shown on the board, right? Okay, so we got the graphing technology to verify that. Use technology to verify graph. Oh, now we got to. So I guess we have to sketch the absolute value as well. So for the absolute value graph, we are going to take any of these negative values. So that 3, this 6. This 9. Okay, we're going to reflect this part. And there's the absolute value, right? So this red. So just do the whole thing in red. So there's the absolute value. So let's say I want to verify that. How can I graph the absolute value?
So
Nice question.
the absolute value graphs, when you reflect them, they aren't going to be curved.
This wasn't a curve. This was a straight line. So an absolute value graph is going to just basically reflect. It will have a V. Okay. Only parabolas have curves.
Oh.
Okay. So straight lines, when reflected, reflect off. It's like a ball, pool ball reflecting off, reflects in a straight line. Okay, let's graph the absolute value. So I think I can do this by going to y equals, but not on that. So go to y equals, I'll move down to y2, and I'm going to graph the absolute value, so I'm going to hit math, go over to num, because absolute value is there. I hit math, and then I arrowed over to num, and I'm just going to do the absolute value of y1. I'm just going to do the absolute value of y1. I've already got y1 in there, so I'm lazy. Instead of re-entering, geez, you guys don't follow along, right? Okay. Here, we'll pause it and we'll rewind it. Okay, watch.
Let's all talk at the same time.
Yes, let's talk. Okay, ready? So the absolute value function is in the math menu. So hit math. Arrow over to num, and it's number 1. So you can either hit 1 or enter. That's the absolute value function. Okay, now, I could just type in -3/2 x minus 3, right? But I'm kind of lazy. So I'm going to just type in y1. Here's how I get y1. You go to vars. See this, vars? Vars. And you hit it. Then you arrow over to y vars. And then you want functions, so you hit enter on number 1. And it brings up the functions, y1. So then I hit enter again, and I get the absolute value of y1. So now when I hit graph, it should graph, or it might regraph. No, so graph that. Now it's drawing the absolute value of that. Thank you. I take a bow, but it won't show up on the video. Okay, so there's the absolute value. So we have graphed this. Graph we're looking at, the graph that the calculator shows us are the same. Okay, so we've used technology to verify our graph. So let's put a little check there. State the intercepts. There are 2. What are the intercepts? Just stating them. So X-intercept is, and the y-intercept is 3. Okay, so the x-intercept is -2, right? That's a place where we cross. In this case, we're not really crossing the axis. Right? We're just going down. We're hitting the axis and bouncing off it. Okay, we're reflecting at that point. And remember, intercepts are numbers. Okay, so it's not the point -2, 0. That's not the intercept. The x-intercept is -2. Y-intercept is 3.
How do you know to put positive 3?
Because we're doing the absolute value graph, not the original graph.
Then I can do that.
Yes. All right.
Keep going to the bathroom.
Got any questions about intercepts? Okay, state the domain and range. So what is the domain of the absolute value function, right? The absolute value of -3/2 x, blah, blah, blah. Set of all x such that x is an element of the reals, right? And the range? Y is greater than or equal to 0, right? Because of the absolute value, we are making sure the y values are positive, or at the least 0. Okay, and then
Why is it x is the element of the reals?
why isn't it?
Because it can be everything.
Because isn't x always going to be greater than -2?
Nope.
Why?
The y is greater than or equal to 0. Okay, so what you want to look at is when are there restrictions on functions? Okay, there are restrictions when there's a radical sign, since we can't have what underneath the radical sign? Can't have a negative. And there are restrictions when there are denominators, since we can't have a 0 in the denominator. Otherwise, there's no restrictions. So you look at that and you say, okay, get the absolute value of -3/2 x minus 3. What value of x can't I put in there? Well, there's no value. I can put any x I want in there, right? Because then I can multiply any number by -3 and then divide that by 2 and then subtract 3 from it. So there's no restriction. Right? The only time you're going to find restrictions is when you have radical signs, because you cannot take the root of a negative number, or when you have denominators. And here, there are values when x is less than negative 2. That's these guys here. And when x is greater than negative 2, that's these guys here. So there are full sets of values. But that brings this point. Express y equals the absolute value of negative 3/2 x minus 3 as a piecewise function.
What does piecewise even mean?
Okay, so piecewise, really, it's just the definition of the absolute value function that we've done, right? The absolute value function says it's x if x is greater than or equal to 0, but it's the negative of x if x is less than 0. So what that means is we want to write this function, negative 3/2 x minus 3. The absolute value of that is equal to, okay? Now, we've got two functions. It's just equal to itself if the values are originally positive, right? So, here's the original function here. If the values are less than negative 2, then we know that this function is positive, right? It's already positive. So we don't want to change its value. We're just going to leave it as it is. All right, I dragged something out of the way. That ended up there. All right, we'll just leave this here. So it's negative 3/2 x minus 3 if x is less than or equal to negative 2. Okay. There. Okay. It's all good. Okay, so the original function was positive when the x values were less than negative 2, right? There it is. Okay, here it is. So we're just going to leave it. Because we're going to say, hey, if your x values are less than negative 2, you're going to be giving me positive values anyways, right? Because you have a negative times a negative, and then you're subtracting 3, but the x values are such that this value will be larger than 3 anyways, so you'll get a positive value. But it will be the negative of the function. So if the original function, that's the purple one up here, right? These values here, if x is greater than negative 2, then the original function is going to give me negative values. In other words, what's here will evaluate to a negative, and I will take the negative of it, making it positive. Okay? So piecewise function says we're going to take the absolute value function, we're going to write it as two different functions, right? It is itself, right? It's just the function itself where the values are originally positive. In this case, any x value less than negative 2, less than or equal to negative 2, gives us a positive value, so we just say leave it alone. It's giving you positive values, don't mess with it. But if the x values are greater than negative 2, then the original function is going to start spitting out negative values. And we're going to turn them positive by taking the negative of it. Okay? And we don't need to simplify this. We don't need to write this as, 3/2 x plus 3. Okay? We don't have to do that. We simply say it is what it is here, and it's the negative of what it is here. Okay? It's not wrong if you simplify it, but it's just, it's just easier to leave it, right? Because it just says it's the original function here, and it's the negation of the original function, right? Take those values, make them negative, because they'll become positive. Okay, question? No. No. Okay, we do one more. Or at least one more. Is this the last page? Okay, last page, right? Last page?
Are you posting this video?
Yep. Somebody's not here. Somebody who shall remain nameless. And so they can watch it. Okay, so for y equals the absolute value of 2x squared minus 5x minus 3, right? So we're going to go through a process. This is just like past worksheets. We're taking you through the process. This is the example. This is the one of, okay, when I get this question in the book, this is the procedure I need to go through, right? And you do 5 or 6 of these, and then on Thursday when you're sitting down to write the quiz or the test, it's like, that's okay, because I'm just going through the process, right? I know I've done this 5 or 6 times. I've done it half dozen times. I know what to do. So here are the steps, right? First, we have to determine the intercepts. Okay, let's do the y-intercept first. It's easy. What's the y-intercept of this? Yeah, so y equals -3. Right? How do you get that? People say, what? How do you get that? You put x as 0, right? And if x is 0, that takes out the 2x squared and the minus 5x terms, giving you y equals -3. Now, for the x-intercepts, we set y to 0. So we'll go 2x squared minus 5x minus 3 equals 0. And how are we going to solve this? Yeah, you could, but you don't want to. We're going to factor it, right? So your first step solving should always be look to see if it factors. If it doesn't factor, then what are you going to do? Quadratic formula, right? Yeah, so it's factor or quadratic formula. That's really all you're going to do here. This actually, so we got a 2x, and 2 times 3 is 6, so I'll put a 3 there, and it's a minus, so I'll put a minus there, and I got a 3, so we'll go with a +1 there. Okay, so check it. Okay, this is the biggest thing, because, it's not, you guys can all factor this, get the 2x and the x and the 1 and the 3, but are they in the right place? Do they have the right signs? So FOIL it out. We get 2x squared minus 6x plus 1x is minus 5x minus 3. Yeah, so it's good, factors. Solve it. X is -1/2 or x is +3. Okay, so we have the 3 intercepts, right? 2 x-intercepts, 1 y-intercept. Determine the coordinates of the vertex. Okay, because if we're going to graph this thing, we need to know where the vertex is. So again, back to first unit, right? I mean, you should be good at this. You did reasonably well. Not that long ago on the cube, right? So it's 2x squared minus 5/2 x. Leave some space, minus 3, right? So we factor out the 2. We can't get rid of it, right? We're not solving. It's not equal to 0. We're not solving. You can't just divide out the 2. We need that 2, right? Because it tells us the shape and the direction of opening. Half of 5/2 is 5/4. And you're going to square that. The square of 5/4 is 25/16. So we're going to add 25/16. Well, not really. What did we just add? We added 2 times that. So we added 25/8. So what are we going to do out here?
Subtract.
We're going to subtract it. See, if you expand this now, you'll get 2x squared minus 5x plus 25/8 minus 25/8 minus 3, and you'll be back at this line, right? So these 2 lines are identical to each other, okay, which is what we want. And -3 is -24/8, right? Because I need that to be 8 so that I can add these 2 together. Okay, so that gives me minus 49/8. Okay, so far, yes, questions? No? It's good? Okay. Okay, use the intercepts and vertex to sketch the graph of this. All right, so where were the intercepts again? What do we have? -1/2, +3, -3. Just ran out of ink. Oh, there it is. And, it's turned black. And the vertex. I never wrote down the coordinates of the vertex, right? We should write that down. So where is that? 5/4 and -49/8. Okay, so 5/4 is like the unerasable line. 5/4, negative, so about down there. Okay, I could find that anyways, right? Because it's halfway between the x-intercepts, but. Okay, sketch. Good. Arrows. Use the intercepts of vertex to sketch the graph. Check. Use the graph of this to graph. Okay, so what do I do to graph the absolute value function? Take this portion that's below the x-axis and put it up here, right? Okay, so we take the negative, we reflect the negative values, which are down here, and reflect them up above. Use graphing technology to verify. Okay, now what do we want to graph? The original? Actually, no, if we just go change y1, y equals, okay, if I just change y1 to negative, no, it's positive, sorry. Okay, let's clear this. Change y1 to 2x squared, 2x squared minus 5x minus 3. Now if I hit graph, first it'll graph the quadratic and then it'll graph the absolute value, right? So here comes the quadratic and then here comes the absolute value function. Okay, and we pretty much have what we have, right? We can verify this, like let's say we find that point here. Let's go second calc. Let's calc a maximum. Let's find this point up here. So first I need to be on y2. I need to be there. So okay, maximum point. Okay, let's graph left bound, move up and around and over top, right bound, and a guess in the middle, guess. And what do we got? 1.249999. Let's call that 1.25 or 1 1/4 or 5/4. And the other one is 6.125. Let's call that 6 1/8 or 49/8. Okay, so good. That matches up with the actual numbers that we had. Okay, so we've now used technology to verify the graph, right? Check. State the domain and range. I don't know how I got these unerasable lines here. Okay, what's the domain? Alright, we know it's all reals, right? The only time it's not is if it's a radical or rational, and this is neither radical nor rational. It's more quadratical. Then what's the range? Come on, it's the same old boring range it's been all day. Y is greater than, y is greater than or equal to 0, right?
Is it always?
Is it always? Is it always? Okay, if it's just straight absolute value, then yes. If we do something afterwards, you know, so if I took y equals the absolute value of x and then subtracted 5 from it, that minus 5 would move the graph down 5, which would put the vertex at 0, -5, and then no, it would be greater than or equal to -5. But you know, we're just doing the absolute value of existing functions. So if it's an existing function, then it has a positive part and a negative part. The negative part will be reflected up above, and the range will always be y is greater than or equal to 0. Okay? You'd have to do something else to it, and mostly I think we'll save those for like 30-1. Okay, express y equals the absolute value of 2x squared minus 5x minus 3 is a piecewise function. Okay, so here, last thing. So we start off by saying the absolute value of 2x squared minus 5x minus 3 is, okay, if it's positive, I want to leave it alone. Okay, so we'll just say it is what it is. In other words, just remove the absolute value. It is 2x squared minus 5x minus 3 if, or when really, but if. Okay, so it's positive, and it was positive, if it's greater than or equal to 3, right? So these values here were always positive, okay? This was the original function. If it's less than or equal to 1/2, negative 1/2, then the values were positive to begin with, okay? So we're going to leave them alone, right? If they were positive to begin with, we're going to leave them. So if x is less than or equal to negative 1/2, or x is greater than and equal to 3, greater than or equal to 3. Okay, so originally, 2x squared minus 5x minus 3 is positive when x is less than or equal to negative 1/2, or when x is greater than or equal to 3, right? That's the original. Okay, we did this last unit, right? So here's the thing, and what's the, when is this greater than 0? So just leave it, right? That's the absolute value. Definition of absolute value function is if, absolute value of x is x if x is greater than or equal to 0. If it's positive, it just is what it is. Otherwise, you take the negative of it. So if it's going to give you a negative value, which is going to happen between negative 1/2 and 3, right? That's where it dipped down below. So if the original function is going to return to you a negative value, then you take the negative of it, right? The negative of this value, which would have come out negative in here, right? You put a 0 in there, you'll get a negative 3. Take the negative of it to make it positive. Okay? Questions? We're done.